Hello, let's continue with the CMSoft case study of fast simulation of heat transfer using C# and OpenCL. In the previous videos, we saw how to discretize the heat equation and come to a final equation that we can simulate using the computer. Just to recap, we saw that we use the y values above and below the current cell to compute the space derivative of the temperature distribution with respect to y, the second derivative, and we use the x values, the neighbors in the x direction of the cell, to compute the second derivative of the temperature with respect to x. And we use both these values to update the value of the temperature in this cell and step forward the temperature distribution in time. Right now, we're going to take a small detour and see how is it that we create an OpenCL OpenGL shared object, and how are we going to use the shared texture to map color and display the values of temperature. It's very counterintuitive to just display numbers to the user, and it's not practical. So we need to create a color code in order to map temperature intensities into colors and create a picture that displays how the heat distribution is happening inside the plate. So using OpenCL template, it's rather easy to bind a texture to a 3D model and then retrieve the OpenCL image 2D object, which is shared with the OpenGL context. So let's get to it. So this is our initial form, all right? And I'm going to go to the load event to show what's being executed here. So first I initialize the height of the image to be 300 pixels and the width 400 pixels. So this is going to be our discretization here, a 300 per 400 window. So this line here, in this line here, we create the OpenCL OpenGL shared context. You can see there that I'm going to create an OpenGL OpenCL shared context. And this -1 here is the device number, which is the GPU that is used to render the OpenGL on your machine. So using -1 is going to work if you have only one GPU, which is used to render the OpenGL drawings onto your screen. So this line is all there is to it. This line creates the shared context. If you want more details of how to create it using CLOO CLOO or C++, I suggest you find more resources over the internet. So this was rather easy. These lines here, they're used to handle mouse events. The mouse we use to set the temperature in the plate. So we're not going to analyze these lines here. You can see through this code if you want to. Let's go to the texture holder now. The texture holder is a square that's going to be drawn onto the screen, and we're going to map a texture that's going to be shared with OpenCL into that square. So the picture you see on screen is in reality a texture that's mapped to a square on the screen. So we create the vertices of the square. So this is the bottom left corner, then the upper left corner, the upper right corner, and the lower right corner. Now we map the texture coordinates This is OpenGL syntax. I'm going to assume you are familiar with this. We set the normal vectors to be pointing up the z direction. And we're going to use the vertex 0, 1, 2, 3 in this order as our square vertexes. Okay? Now we're going to create a 3D model, which is going to use the OpenGL begin mode quads. It's going to draw a quad on the screen, a rectangle. We're going to set V as the vertex data. We're going to set the texture coordinates, set the normal data, and set the elements. Now we're going to create an empty bitmap and set it as texture to our 3D model, the M. And this is very important because later on, this line sets the bitmap. It transforms it into an OpenGL texture and sends it to the GPU. And later on, in this line, we're going to use OpenCL Template to retrieve an image 2D object, which is an OpenCL object. It's going to be retrieved from an OpenGL texture. So these lines here, this line creates the bitmap, sets it as texture, and here we retrieve the bitmap in order to be able to use it in OpenCL. Now, how do we use this object? Well, let's get to the preliminary tests. Let me collapse the texture hole, get to the preliminary tests, and show you how this is done. So I have an image here, which is an OpenCL image, and I'm going to want to write to it. So this is the OpenCL kernel. This is just a test kernel. What it does is the following. It gets the X index of the work item, XY coordinates, transforms it into an XY coordinate. Then we create a value, a color value, that's 0 red, 0 green, and 1 blue. That means a blue pixel with no transparency. And we set the value of the image in the coordinate XY to the desired value, which is 1. I mean, it's blue. So this is our kernel, very simple. We just use the BMP as a regular OpenCL image. Now we compile this code, create a new kernel K, which is the kernel image test. And at this point, we're ready to use this kernel to operate on the OpenCL image and produce some dummy results. We're just testing the interoperation of OpenGL and OpenCL. So how do we do that? Well, we need to stop OpenGL from using that image so we can manipulate it using the open computing language, OpenCL. So we need to acquire the element. In native OpenCL, you'd use a command specific to include acquire GL element. Now we're going to execute the kernel. So see what this is going to do. It's going to use the image we brought from OpenGL as an argument, and the global work sizes are going to be 50-50. So it's going to set a blue square of 50 width and 50 height into the blue color. And then when I'm done using this image, I'm going to release it back to OpenCL. So I'm going to put a return here in the code, just so we can see what happens. So let me run this code. Of course, there's an unreachable code detected. And what we see, voila, here's a blue square, which is what we programmed. Now let's change that code and make it red and bigger. So I'm going to take off the 0 here, put a 1 here, means red, 100% red, 0% green, 0% blue, and I'm going to have a 150, say 80. Let me build a rectangle. Now I run this code. And voila, here I have my red rectangle. Using OpenCL OpenGL interoperation directly in GPU memory. So I don't have to transfer data back and forth. I can execute some code directly in GPU memory and have my results be displayed on screen without my CPU even knowing what these values are. Let me remove this return here. Back to our presentation. Okay, so we saw briefly how to share OpenCL OpenGL objects using OpenCL Template. If you want to, you can go ahead and browse the OpenCL Template source code, or grab some CLGL interop objects in C++, for example, if you're interested in using C++. So next time we're going to analyze and see a function to map intensities, temperature intensities, to color value and display a beautiful picture to our users so that they can see the heat distribution along the plate. Thank you.